student. I am Dr. Shikha Pandey, Associate Professor from Institute of Aeronautical Engineering. Today, I'll discuss about the waste as a fuel. So, for this lecture series, for this solid waste management, as we have already discussed about the transformation and processing of waste. So, in this whole picture, now I will discuss about the transformation of waste. So, this is the whole picture related with the waste generation. First of all, it is the waste generation from the point of its generation to its final disposal. All are considered under this whole solid waste municipal solid waste management. So as we have discussed about this primary collection method, secondary collection method. So after secondary collection method, processing and transformation is there. So in transformation process, today I will discuss about the waste as a fuel. As in the previous classes, I have discussed about the fuel waste as a fuel. I have discussed about the plastic recycling and paper recycling. So all these are related with the processing and transformation of waste, because these are the dry matter and these are the composition and uses conversion of dry matter. And next is the waste as a fuel. So first of all comes to the definition, why this waste as a fuel. Waste to energy plant is using to convert waste as a fuel, because in waste to energy plant, waste, that is municipal solid waste, MSW, it is used as a fuel. So this MSW is sometimes also called as garbage or trash to produce steam in a boiler that is used to generate electricity. Waste to energy plant burns MSW, that is also sometimes called as garbage, and produces steams. So by the burning of this waste like MSW, it is called, it will generate electricity, and it is going to produce steam in a boiler that is used to generate electricity. And why this MSW? Because this MSW is having a very high mixture of energy rich material like paper, plastic, yard waste, and products made from wood. So wood product also. MSW is a mixture of energy rich material like paper, plastic, yard waste, and wood product. That's why all these are having very high energy rich material. Their heating value is very high. That's why this waste as a use as a fuel in waste to energy plant. And what happened in this plant, because of the burning of waste, that ash volume is going to be reduced up to 87%. So waste to energy plant reduces 2000 pound of garbage to ash, weighing around about 300 pound to 600 pounds. That weight about 300 pound to 600 pounds, and they are going to reduces the volume of waste by about 87%. The volume of waste will be reduced by about 87%. So that's why this MSW, this waste, is used as a fuel in waste to energy plant, because by the burning of this MSW, it is going to be generate very high heat, and this is going to be produce steam in a boiler, and that steam can be used to generate electricity. And MSW is having a very high rich material such as like a paper is there, plastic, yard waste, and wood product. And waste to energy plant produces 2000 pounds of garbage to ash, weighing about 300 pounds to 600 pounds, and they are going to reduce the volume of waste by about 87%. So this is the differences between waste incineration and other combustion system, is that the waste incineration process treat incoming waste with great variation. The primary difference between waste incineration and other combustion system is that waste incineration process treat incoming waste with great variation, and the practical design limits the allowable variation of waste composition. So before designing this waste to energy plant, the important parameter is like that. First is the moisture content, volatile and organic matter of the waste, and then fixed carbon and total inerts. So that these are four are the, and calorific value also. So these five are the important waste parameter that is used for the viability of its total energy recovery. So moisture content should be less than 45%. Organic or volatile matter is there, that is more than 40%. Fixed carbon is less than 15%. Total inert is less than 35%. Calorific value is more than 1500 kilocalorie per kg. So these are the perfect parameter, these are the perfect range that could be viable for the energy recovery from this waste to energy plant. And for this waste to energy plant, this MSW is used as a fuel to produce steam. That steam is going to produce the electricity. And these are the some practical design are there. Some design, this design will allow variation of waste composition. The primary difference between waste incineration and other combustion system is that the waste incineration process treat incoming waste with great variation. Now comes to the next point, how this waste to energy plant is working. So first of all, we'll discuss about the working condition of this waste to energy plant. So waste is dumped from garbage truck into a large pit. From a garbage truck to large pit, garbage truck is there. From this garbage truck, it should be disposed on the large pit, and a giant cloud on the crane grabs waste and dump it in a combustion chamber. So combustion chamber is there. So in this combustion chamber, a giant claw on the crane is there, and that crane is going to grab waste and dump it in this chamber. The waste is burned, and that is going to release heat is releasing at this stage. So what happened after releasing the heat? The heat turns water into steam in a boiler. Heat is going to turn the steam in a water and in a boiler. Due to the heat, due to the heating, the boiler will start turning, and the steam is going to be generated. And the high pressure steam turns the blade of turbine generator to produces electricity. The high pressure steam turns the blade of turbine generator to produces electricity. An air pollution control system remove pollutants from the combustion gas before it is released through a smokestack. An air pollution control system remove pollutants from the combustion gas before it is released through a smokestack. So one device is there. That device is going to control the air pollutants. That because in this waste to energy plant, obviously MSW is burning. So because, and this MSW will have more contaminants also. So because of the burning of the waste at a very high temperature, maybe this will be going to release some toxic gases into the atmosphere. So by to prevent these things, air pollution control systems are there. That system is going to remove pollutants from the combustion gas. That control system will remove the pollutants from the combustion gas before it is released through the smokestack. Before releasing it from the smokestack, ash is collected from the boiler and the air pollution control devices. So at final stage, ash is collected. So the main motto of this waste to energy plant has been reached. First of all, this MSW can be used as a fuel to obtain energy from the plant. And next point is that by using the MSW is burned and ash is collected, so it is going to remove approximately 80% of the total volume of the MSW. So volume reduction, first is the volume reduction is also achieved. So next is the volume reduction is also there, and due to burning, and that waste is also utilized in waste to energy plant to obtain very high electricity. So it can be used. So this in this way, this waste is very much beneficial because it is used as a fuel in a waste to energy plant also. And with this and it is providing a very high calorific value because this will be mostly dry matters are there. So because of this dry matter, less moisture contents are there, and they are having very high heating value also because some wood products is also there. And the waste, because of the burning of the waste, sometimes what happen, air pollution will come because some contaminants is also there. So because of this contaminants, the air pollution control devices is also there. Some of the devices is used to filter the pollutants from the air, and by filtering the pollutants from the air, combustion gas before it is released through a smokestack, and then ash is collected from the boiler and the air pollution control system. Next point is the incineration, is the process of burning hazardous material at a temperature high enough to destroy the contaminants. And incineration is conducted in an incinerator plant. Incinerator chamber is there. In that incinerated chamber, this incineration process will be carried out. This is a type of furnace designed for burning hazardous material in a combustion chamber. So, due to this, see, you can see this is a picture of this incineration plant, incinerator plant. This is feed is there. So, from feed, waste is added. This waste is added, and it will goes from the first chamber fuel is there, and it starts burning. So by the burning of it, ash will come out, and then again second chamber is there. The second chambers, from second chamber also gases to the air pollution device. It will goes to purification of air, and then first combustion chamber, then second combustion chamber, then fuel. Again fuel is there, this fuel is there. So in this way, it will be burned at a very high temperature in incinerators, and this incineration is called as a furnace, and it is designed for burning hazardous material in a combustion chamber, and it is a process of burning hazardous material at temperature high enough to destroy contaminants. Incineration is conducted in an incinerator plant, and this is a picture of an incinerator plant where one feed is there. From feed, air is passing and the fuel is there, and then again second combustion chamber is there. First one also ash is collected, and second one also. And after second combustion chamber, gases to pass through the air pollution control devices. Now, the how to design this incinerator, because designing of incinerator is very important. Designing of incinerator is very important. How to design this, what are the important factors that should be keep in mind while designing the incinerator? So first of all, based available data on the amount, means the amount generation, the generation of solid waste should be keep in mind. Generation of solid waste from that particular area, their available data should be keep in amount, means how much amount of waste is generated, and the composition of each waste type, and the composition, which type of waste is there. First of all, type of waste and composition of waste, type of waste, and next is the composition of waste. So which type of waste is there, what are the composition of the waste, and next is the effect of future change in waste management. What will be the future change in waste management? Because when we are designing an incinerator, that will be considered for the next few times also, not for the present 10 years, it is up to a future also. So what will be the future changes in the waste management? That some background study should be done. Waste led to incinerator plant consists of variation of waste, like some domestic waste, some commercial waste, institutional and industrial waste. Means different type of waste will lead to the incinerator plant, and that will be called as some great variation of the waste. Waste lead to the incineration plant consist of domestic, commercial, institutional and industrial waste also. So great variation in the waste is there. Great variation in the waste is there. Great variation in the waste is there. And next is the street sweeping and construction demolition waste are not suitable for incineration, as they contain large fraction of incombustible matter. Obviously, some C and D waste, that is construction and demolition waste. Street sweeping, street sweeping is there, that is also called as non-combustible waste. So only those type of waste can be used, those who are combustible in nature. So two type of waste is there, combustible and non-combustible. Non-combustible material are those that are like some street sweeping, some construction demolition waste, which cannot be suitable for the incineration plant, and it contain very large fraction of non-incombustible matter. And the combustible waste are those waste that can burn with a high heat capacity, such as cardboard, such as like wood products. So only those waste which is combustible can be used in this incineration plant. So these are the important point that should be keep in mind while designing an incinerator plant. First of all, what is the amount of what amount of waste that is generated, and type of waste that is generated from that place, and characteristics and composition of the waste, and what are the effects of future change in waste composition. Waste lead to incineration plant consist of domestic, commercial, institutional, industrial waste, means like a great variation of waste is there. Some street sweeping and construction and demolition waste are not suitable for incineration as they contain a large fraction of incombustible matter. Next, you can see this is the picture. This is the recent waste generation data shows that the presence of huge quantity of packaging material. More now, there is a recent waste generation data shows that the waste will have more amount of these packaging materials like some cardboard, some hard paper, some cardboards are there, and these are the some incombustible materials. So in incombustible material, first is the demolition waste. Demolition waste cannot go for this incinerator. It can go for recycling or inert waste from street sweeping. From street sweeping, many inert waste are there. So these two are incombustible waste. Incombustible waste, and these cannot be go for the incombustible waste. It cannot be used for the incinerator plant. So this is the recent change of the trend of the waste. Nowadays more waste is generated will having more amount of huge quantity of packaging material also. Now, important parameters that should be keep in mind while designing an incinerator. First is the heating value of the waste. Heating value of waste. So it will connect with the per unit weight or volume of combustible material that is completely burned. It is a heat generated per unit weight or volume of combustible material that is completely burned. Heating value is roughly proportional to waste that is combustible. And in combustible, we are excluding the moisture content and ash content. Like heating value will roughly proportional. It will be proportional to the waste that is combustible only. It will be proportional to the amount of waste that can only be combustible. And for this combustible point, moisture content and ash content it can be excluded. And the heat generated per unit weight or volume of combustible material, it will be completely burned. And next is the carbon content of the combustible fraction. Carbon content. First point is the heat generated per unit weight or volume of combustible material that will be completely burned. Next is the heating value is roughly proportional to waste amount that is combustible only. Content of the combustible fraction. Next is the moisture content. So moisture content is again very important part because the moisture content is a critical determinant in the economic feasibility of incineration process, since energy must be supplied for evaporation of water and in raising the temperature of the water quality. Critical moisture content is a very important parameter for knowing the economic feasibility of incineration process, because energy or heat that must be supplied for evaporation of water and in raising the temperature of the water vapor, and it is generally found to be very much high in the waste that will contain more proportion of food waste. And next is the ash content. Ash content is the substance left after ignition of 550 degrees celsius, means after the ignition at the rate of 550 degrees celsius, those things that will be left over is called as ash contents, means those waste which will be left over after heating at the very high temperature like 550 degrees celsius. So moisture content, ash content, all are important parameter that is related with this incineration practices. Now, waste characteristics. So now we are going to discuss about the characteristics of the waste, means what will be the actual, what will be the required determined concentration of the waste characteristics as a fuel. So first is the moisture content that will be donated by the letter W. Ash content is A, and combustible solid is called as C. So W is the moisture content. So moisture content should be between 15 to 35% after drying at 105 degrees Celsius. So weight W is a moisture content that should be 15 to 35% after drying it at 105 degrees Celsius. Ash content or some inorganic content is like 10 to 25% after ignition at 550 degrees Celsius. After the ignition, after burning it at a 550 degrees Celsius, 10 to 25% of inorganic content is there. And combustible solids or organic solid is like 40 to 65%. It is like a combustible solid in a waste. So above known characteristics can be used in a tenor diagram to examine the waste can be combusted without auxiliary fuel. So this is the standard data, this is the characteristics of the waste that we are putting in the tenor diagram. So in tenor diagram we'll examine the waste will be combusted by itself only, or either it will need some auxiliary fuel, means it will need some extra fuel. So this is the perfect data, like combustion process does not require auxiliary fuel if data are located within the shaded area, means if the data is like that, if the moisture content of the waste is less than 50% and ash content or inorganic content will be like less than 60%, and combustible solids or organic solid is like more than 25%. If it will be more than 25%, A will be less than 65%, W will be less than 50% moisture content, then the combustion process does not require any extra fuel and it can be burned very perfectly. So, to determine the burning of waste as a fuel, these are the important factors we should keep in mind. Moisture content should be below 50%, ash content should be below 60%, and combustible solids or organic solids should be more than 25%. So, these are the important characteristics that can be used in the Taylor's diagram to examine if the waste can be combusted without auxiliary fuel. So this is the tenor diagram. So in tenor diagram, what happened? We have to consider a point. See, this point is there. We are considering this point. So from this point, how to find the corresponding value of W, A, and C from the given point? For finding W, draw a line starting from the given point parallel to percentage combustible intersect the W side of triangle. So that's why we are line is there, that is in this direction, so it is 40%. So it will be like this from a point it will be starting. So point is there in a Tanner diagram. So after the finding the corresponding value of weight or ash and combustible content in a given point, so for finding W, draw a line. W is equal to, like, draw a line starting from the given point parallel to percentage combustible to intersect the W side of triangle. It will intersect the W side of triangle. Intersect the W side of triangle. So W is equal to 50%. W is equal to 50%. It will intersect the other side of triangle. So here W is equal to 50%. Also you can say that, or it is 40% also. W is equal to 40%. Next point we are discussing. Similarly, for finding A, draw a line from a starting point parallel to percent moisture to intersect the A side of the triangle. So again we are drawing one point from here, and this will be get the next point. Just like this, from this point we are getting from this side, this is 40%. So for finding A is like ash content. Draw a line from the starting point parallel to percent moisture, means first of all we find it a moisture content, that is W. From here only we'll draw a line like this. So A is equal to 25%. Lastly, for finding C, draw a line parallel to percent ash to intersect C side of triangle in a tenor's diagram. So like this we will draw a line. So C is equal to 35%. So in tenor diagram we'll visualize, we'll make it effective that this will be a perfect condition for this combustible or incinerator process. So 3 point is there, from a point is there. We first of all what we'll do, we'll consider a point. This point will give you idea about the moisture content, ash content, and carbon content. So for finding W, draw first of all we'll draw a line to starting from the given point parallel to the combustible matter. Obviously we'll draw a line to parallel to the combustible material. Then again we'll find the ash percentage, moisture percentage, and combustible percentage. In a triangle is there. In this Tanner diagram, one triangle is there. So first of all it will discuss the moisture and percentage ash. It will shows, and next is the combustible material C. So by pointing line, this three direction will find. This three direction will find like the moisture content, and then total ash content and carbon content. So the moisture W is equal to 40%, W is equal to 40%, ash content is equal to 25%, next carbon content is equal to 35%. Now comes to the next point. So find out the following value lies on the tenors diagram. Now we are getting the some three data is there. W is equal to 15%, ash content is equal to 35%, and carbon content is 50%. So begin with plotting 50% of moisture and the percentage moisture side of triangle in tenors diagram, and from that point draw a line parallel to combustible side. This one only, this one only you can see that this is the line is there, that is moisture content and the percent moisture side of triangle in tenors diagram. So from that point we'll draw a parallel line, that will be a combustible side, that will be reflects, that will be show you the combustible side of the total waste. So next is what happened. Next, what we'll do in next plot, 35% of ash content is there, and the percentage ash side of triangle. From that point, draw a line parallel to percent moisture side to intersect the previous line. 35% of ash, and the percent ash is there, that ash side of triangle, and that will be from that point draw a line parallel to percent moisture and the side to intersect the previous line. Lastly, plot 50% combustible material and the percentage combustible side. From that point, draw a line parallel to percentage ash side to intersect the previous lines, and the intersection point of the above three line will give a point corresponding to the given value of W, A, and C in the tenor diagram. So this is all about the tenor diagram. You can see that this is the point is there in a tenor diagram where this is the moisture content as percentage and combustible material is there. So from here we'll draw a point to find the moisture combustible moisture, because it is already given in the data. W is equal to 15% and ash content is equal to 35% and C is equal to 50%. So in this way we'll find it by making a parallel line by intersecting each other, and this is the tenor diagram that can be used to understand the original moisture content, ash content, and combustible material in a solid waste. So what means this from this standard diagram, it is clear we will use this standard diagram to calculate the moisture content, ash content, and carbon content in a solid waste. So what will be the conclusion? We are at the conclusion slide. Like waste to energy and energy from waste is one of the most effective and efficient technology for reducing the waste volume. So volume reduction is an important thing in this waste management. So volume reduction like waste to energy or energy from waste is a very effective, and energy recovered from the waste can be used for thermal or electricity generation. So this is also a very important point. That's why this waste as a fuel is a very important topic. And in the next class I will discuss some problem statement based on this tenor diagram and what will be the heating value for this tenor diagram. So this will be some of the references of the some of the textbook that you can use for its in-depth knowledge or some more knowledge on this topic. Now thank you, and I'm concluding this lecture. Like in this lecture I have discussed about the transformation of waste. So waste is a mixture of MSW. So this municipal solid waste can be used as a waste to generate electricity in a waste to energy plant, because in a very high with a very high energy burning, this is going to be produce electricity by moving a turbine with the steam. It is going to produce electricity. So and after this burning, the ash will be like 80% reduction in the volume reduction of the waste. So this waste to energy is a very important, a very good effective management of MSW, because it will be used to generate electricity also. And second point is the volume reduction is there, up to 80% of the volume is going to reduce by the burning of waste at a very high temperature. And in the burning of the waste, some air pollution devices is also there, so that the device, after filtering the air, the air will come out, so it cannot pollute the air also. Because by the burning of waste at a very high temperature, some toxic gases will be released. So to avoid these toxic gases, it will be passed through some air pollution control devices like electrostatic precipitator and cyclone settler is there, so that the air will come out with a clean air will come out. So this is if you have any queries, if you have any question regarding this lecture, you can write in the comment box, or you can mail in on my given mail id, that is shikha.pandy@gmail.com. So thank you for today's lecture.
Like, share and subscribe. Hit the bell icon for more updates.